First piece we're going to do today is going to be item number 27, the Eccentric hub. Now this is really not a big deal. Yeah, it could be a problem if you don't have a 4-jaw, but you might be able to get creative with shims if you don't in a 3-jaw. Now let's take a look at the fragile nature of this little feature right here. If you were to squeeze that in a 3-jaw or a 4-jaw, chances are you're going to do some damage to that. It's kind of skinny. So what we're going to do is we're going to do the offset first, then we're going to do all this, and then we're going to part it off. So it's going to start off in the mill. We're going to stand this up in a V block in the mill, indicate the OD, move it off center 188, and do this feature right there. Now we have a target to indicate when you put it in the 4-jaw or the 3-jaw with shims or eccentric collar, however you decide to hold it. I'm going to do it in a 4-jaw. And we're going to do it from this piece of stock right here. So this is going to be solid, sticking out of the chuck this way. And this is what I call a knuckle knocker feature, because when this thing is spinning up at 700, 800, 1000 RPM, and this is just coming around like a little camshaft, you get your finger in there and it's just going to remind you real quick that you got too close. So let's not do that. The part will come off the end of this part thusly after the eccentric is turned. So we'll do the eccentric first, then the body, undercut, part it off, and it should basically be done. There is no reason to face this backside off other than cosmetic. So if you want to do that, go right ahead. And you can certainly do that easily once you put the set screw in here. Put it back on the shaft, and who cares if it's running out eccentric. It's this surface here that is the important part, so it really doesn't matter if it's oscillating. You'll see a little bit of funny stuff going on in the finish, but that's entirely up to you. Alright, let's put this thing in the mill and let's make an eccentric hub. Let's take a look at the simple setup for this part. I have a pair of 3/4 parallels with a 1/2 inch in between just to space it out a little bit. Aluminum V-block on the stationary jaw. Nothing on the movable jaw. I'm just going to come right into it. A tool bit underneath to keep it up. And as far as indicating a part in the spindle, keep your indicator close to the part but not on it initially. Look at the gap left and right. That's about 1/8 of an inch, right? This side's a little bit closer, so you know that the part has to move that way. Don't keep the indicator in contact with the part when you do this initially. Visually look at this little gap right here to the part. Left and right, in and out, otherwise known as the X and the Y. And when you can see that you have something that looks relatively close, then drop the needle down in contact with the part and sweep it home. Okay, let's get this thing on a tripod, make that happen. Boy, I like it when it's focused. Once you get it zeroed out, set your dials to 0, set your digital to 0, and shift off center the 188 on the print. Before I start the drilling operation at the 188 offset, I'm going to take a nice little fly cutter pass across there and clean that face up. First part of the process is to simply drill and ream a 375 hole 188 off center. The part is 562 thick. I am going to go approximately 700 with the drill and the reamer. And yes, I'm going to use a center drill for everybody that says how come, because I like it better. The supplied material is cutting a lot like what's called lead loy. It is a heavily leaded cold roll and known for ease of cutting and superior surface finish. That's a good thing. I will run the reamer in until I feel it bottom out. No risk of exploding it, and if you don't have excessive pressure on it. Run the reamer slower than the drill. Continuous feed. Very nice finish. 375 pin. Beauty. .376 pin. Nada. Okay, over to the lathe. Let's turn some journals. I have a 375 drill blank. Yeah, it's a gauge pin. Okay, I'll be honest. There's a 375 gauge pin in my chuck, a drill chuck, and there's a 4-jaw chuck mounted to the machine. You could do this in a 3-jaw chuck if you had the appropriate size shims for this, but I'm just going to do it in a 4-jaw just because. I will hang the part from that 375 pin, and that will get me close enough in the initial setup when you need 19 hands to do the job. I'm going to move one extremely out of the way. That'll be the low side. Put the part in. Leave it hang out far enough for your parting operation. And rotation at this point really doesn't matter. Just want it to be snug. So I am spinning the part on the pin and trapping that back shim in there. And I'm going to do my, let's call it Y-axis jaws first. Pressure. And the final shim. Pretty close to me. I will snug up on the shims, especially that. Wow, thank God for cameras. Now look at that. I couldn't even see that from where I was standing. I'm going to snug these up. I'm going to indicate the face of the part, make sure that the face of the part is running true, or you can't trust the alignment of that bore. Then I'm going to align the OD of the pin. Face first though, that is important. Straighten out that shim first, that's important. Look at that. What? That's terrible. Boy, that is pretty. Look at that. I like it. You can also, should you care to, indicate the top of the pin. Rotate it 90 degrees, indicate it again. See what we got. Boy, that is really close. Almost ashamed to mess with that. I'm going to gently snug these in sequence. Once the face of your part is true, double check the concentricity of the pin before you start the cut. All right, once you've successfully indicated the part to run basically true and square, go ahead and turn the shoulder on it. This is a non-functional feature. This is strictly to relieve some of the material off and give you a collar appearance for the set screw that holds this valve driving cam to the crank. Let's cut it. All right, you can dial this thing concentric with the 4-jaw should you care to. I personally care to put it back into 3-jaw and dial it in for the next operation. Let's do that. Back into 3-jaw, I am going to indicate the top of the pin to run relatively true before I start any groove work on this, because this is going to drive a cam, or actually this is the cam, and if this is not running true to the hole, then the cam will be running out because the hole is going to be running true at assembly. So try to true up that hole the best you can, not concentric but straight, and then we'll work concentric from the OD. The groove is 252 wide. I prefer not to use a 252 wide tool for sake of chatter. I'm going to work this with a much smaller tool and walk the tool back and forth to achieve the dimension. The very next step is to put the undercut in the OD of this part. I am looking at the banking surface because it's the eccentric is out. It's in the chuck this way right now. The side hanging out. I am looking at this surface right here, origin surface, as my 0 point. Let's flip it upside down. Actually, let's go to the technical drawing I have. There you go. The face of that part is my 0 point right here. Look at that. Magic focus pens. I like it. I should have that just right on the part. When I bump my tool up against this part, I know that I have to move in the thickness of my tool before the tool will be on the edge of the part right here. All right? Simple. Knowing that, take the flange that you want to cut plus the thickness of the tool that you're going to be using, and that is your first move from 0. And on this one it's 135.5 because my tool is 073.5 plus the 62 front wall, 135.5 right there. That'll be the first plunge for the tool. And the second one, just strictly add the two numbers together. 62 and 252 gives you 314. So anything in between these two numbers is fair game for removal. This is the diameter that we're shooting for, 0.999, and that is just about 25.4 millimeters. Pretty close. I'll do the translation for you, but that's what we're shooting for. You can check it any way you want. 252, your micrometer may be able to get in there, but whatever you turn this to, remember that this has to fit comfortably inside the collar that drives the rod, that drives the valve, that drives the engine. All right, that's how I'm going to do this. I'm going to bump the tool, make the shift for the 135.5. 314 is my max movement of my carriage. If you want to, you can find out what the center of those two values is and go plus or minus exactly the same value in both directions. Not an impossible thing to do. Subtract this from this, divide it by 2, add it to that. That becomes your center, 0, and then that much in both directions. Now that you're completely confused, let's do it. Maybe it'll make more sense. Okay, just like I described on the bench, the first thing I'm going to do is register the tool against the lower face here. That'll be my 0 point. When I move the tool over, I'm just going to touch the OD of the part, and I'm going to look for a nice even track from the tool. And if it's not even, I'm going to bump the tool one way or the other until I do get a nice even track. That is critical for a true diameter on the undercut you are about to make. I am now in between the front flange and the back flange visually on this part. I'm going to run the tool in and I'm going to look for a nice true flat cut. See what we get. That particular witness mark on the OD of the part would indicate that the tool is leaning to the right because the left side is making contact. So it's out of square this way. It's coming in at an angle. So the leading corner is the one closest to this side right here. I need to bump the tool in that direction a little bit, and we'll try it again. I will also double check the concentricity of the part and the 0 face of the setting of the tool after the adjustment. Remember, if you bump the tool, you're going to lose the 0 face, so you must start completely over. Not a big deal, just be aware. Accelerate the process. I'm dropping a scale on my cross slide to give myself a little bit of reflection underneath the part. And I'm going to look down on top of the tool when I change the angle. Tool is successfully re-zeroed. I had to bump that tool 52,000, so that clearly illustrates how important it is to re-zero against the face of the part to maintain a good track. I'm going to take the first plunge at the first reading that I showed on the paper, second plunge at the second reading, and that is going to give me a visual barrier to work back and forth from. Okay, that way it's just a lot easier on your mind. You don't have to mess with numbers. You have something physical to look at. And concentrate on that little scratch mark right there and watch the initial contact of the tool this time once it's straightened out. it should be at least twice that wide. There we go. If everything went well and the tool is truly straight, you will not see a tool width remnant at either end of the undercut. If the tool is tracking sideways, you're going to see the transition line where the tool is no longer true to the diameter that you just turned. So look for that little witness mark that says the tool's out of whack. I am very close to my finished diameter. I'm going to check it, but I'm going to cheat and check it with a groove mic. And if you do a lot of work like this, it's worth having one. I'm shooting for $9.99 exactly. This little guy right here is going to get me there. That's cheating, but hey, I can cheat. $20 more. On this particular dimension, $9.99 is the target. It is better to go undersize than oversize. Undersize will give you a little bit of play in the collar that goes around it. Oversize will make it too tight and the collar will grab it. So I'm going to shoot for at the most $9.99. I'd be quite happy with the thou or two under. If your tool is not dead sharp, you can expect these surfaces to rise when you plunge the tool in. Just to be safe, take a file and knock these corners down. That is the next step. Well, actually I have a tool set up, so I'm going to do it with a tool. A real nice finish is it's recommended in the undercut, because whatever finish you have in here is going to translate to an aggressive surface inside that red brass, red bronze. Now my instrument of choice for lining this up, and if you're a viewer of this channel, you'll know that this is my trick, and I use a razor blade. Just scrape it across the front. That little ticking sound tells you that you are proud of the surface with the parting tool. Move the tool in until that goes away. I'm moving in 1/2 thousandth at a time. Still got it. Still got it. And gone. Alright, we are looking for, I am looking for 3/8. 375. I'm going to go 376, just in case the tool digs, cuts, whatever. 376 it is. Make sure it's on center. I'm going to part this off at the same speed I did the groove at, 425 RPM. I'm going to go very shallow initially, put a file in the groove, break the back edge, and then continue the cut. let's take it over to the bench, take a look. All right, let's take a look at it dimensionally. Should still be a 375. I expect this to hang up on the back side, which it does. The parting operation is an interruption because it's off center, and it will hammer the hole closed. Be sure to deburr that back side sufficiently, maybe even float the reamer back through there. Once you tap the hole in this, it's a really good idea to put the reamer back through there. All right. This, I believe, is a 625 diameter in the front. Should be. 625.5, close enough, right? 375 on the thickness. 376.5. Told you I was going to set it high so that if it dug in, it would cut, right? These should be about 62 each. And I am A-okay with that. This dimension here is 254. Let's see what it measures. 252. Make sure that the cam that you put on there is cut to under this dimension so you don't pinch it. Now for me, I am going to deburr this hole. I'm going to run this across some sandpaper. I'm going to do the same thing on this face right here. So I'll sand it out this way. I will sand it out this way. And then I'll come back. Let's put the 540. I don't know why they use a 540. That's pretty small. Set screw so that you can lock it down to the crankshaft. Boom. Let's do it. The one dimension I did not check for you was the groove. Check it at both ends. $9.99 on that end. It's like $9.99 to me, guys. Let's find the center. There we go. That's about 3/10, 4/10 low in the center. Couple of tenths under all the way across. Way I like it. Now for those of you not familiar with this, this is a blade mic, groove mic. This is ideal for checking O-ring grooves. I will be using this on the piston, but I will show you another way to do those grooves on the piston so you don't have to guess at it or guess at it. These are ideal. Some of them have a friction thimble back here, which this one does not. This is the friction here. So once this meets with a specified resistance, this just no longer turns. Nice little instrument to have. Not all that expensive either. If you do a lot of work like this, go ahead and get yourself one. The 540 hole is next. Now here's a question I know that you're going to ask, so I'm going to answer it before you ask. This raised boss on this part is 625 across, and this is 1.125. Imperial, well, it's a 1/2 inch difference between this diameter and this diameter right here. That means, looking at it this way, it is 5/8 of an inch from this plane to the center. Right? You know that. It's the radius. It's the radius of this, 3/8. What's the difference between the two radii? 1/4 inch. 1/4 inch pin. When this comes around and it rolls flat against a 1/4 inch pin and traps that pin against the surface, both of those centers are now on the same line, because the 250 plus the radius of this is equal to the same radius as that. Does that make any sense at all to you? I know it might be kind of hard to visualize, so let's look at it in the actual setup. And I may need 12 hands to do this, so forgive me if I fumble around. Alright, let's say you have your part sitting there like that. As this part rotates, that elevated boss will get closer and farther away from this 1, 2, 3 block. What you want is the gap between the OD of that boss and this block to be the difference in the radius of the two pieces. That's where the pin comes in. When you spin this part, where the large diameter is trapped against the block and the eccentric is now trapped against that pin, those two center lines are in line vertically. For sake of this machining operation, I'm going to trap them 180 degrees opposed. I want it down. And this is not as easy as it looks. Okay. I've got the part pushed against the back jaw. It is rotated against the body. The eccentric is holding this pin. I'm going to lay a little helper block in here. Close the vise. Boom. Those centers are now clocked vertically on the same center line. Within a degree or two, I would guarantee it. Depending on how tight you hold your dimensions, your diameters, knowing your stock, knowing your boss, the pin is the key. Now you can either use an edge finder on one of the sides, or you can sweep the undercut, and that'll put you right where you need to be. Using an edge finder, you can find the location of the hole as given. Everything zeroed out. I trimmed the undercut side to side, found my zero in the middle, use an edge finder off the back to find it here. And you will definitely feel when it breaks through to the bore with the center drill, the drill, and the tap, so that's no big deal. If you hit your numbers and you think you need to cheat a little to keep your center drill from dragging on this surface right here, go ahead, it's not going to hurt. And hopefully we get a nice clean thread in there. Let's see what happens. Same tap that I'm using for the cast iron, 3 flute, 540, spring-loaded tap guide. Away we go. Alright, for sake of not snapping the tap off or influencing anything else, I'm going to take it out right now. Take the tap out by hand. And that is the conclusion of the eccentric. I hope you like that trick where you put the pin in there. Put the pin on the one side and rotate it until they both bump, line up the center. That'll get you right where you need to be. And there's a 540 set screw going through there. Not a bad little project. Starts on the mill, finishes on the lathe, goes back to the mill. Get ready for it. It's pretty much no other way to do a piece like this. Anyway, I hope you enjoyed it and hope you got something out of this you can use. There you go. He's in more of a hurry to get out of here than I am. Thank you very much for watching as usual. And I got one more treat for you. Not really a treat, but somebody had said, gee, I wish you showed it. So stick around after the goodbye and I'll throw a real quick clip in there for that. Once again, Joe Pye, Advanced Innovations in Austin, Texas. Thanks for watching. Stay well. All right, in regards to this little guy right here, I made a comment last week or the week before, could have been last year, I don't know, that the whole part is only going to be about that big, and somebody commented, oh man, I wish you'd have shown that piece next to the print when you were done. So, okay, here you go. There's the piece, there's the drawing. Big difference. That wasn't far off, it's just about that right same size, right? Close enough. Anyway, there you go. Make sure you look at the numbers on the print before you say, oh yeah, I can do that. Part might be a little smaller than you think. Like a lot smaller.